Alright guys, today we're going to talk about slope. And when I say the word slope, you might be thinking the slope of a mountain, like when you're skiing. And when you think of slope of a mountain, if the slope is super steep, then you're going to go down the mountain super fast, right? So the slope is kind of how fast it's changing vertically and horizontally. So in math, we have the word slope as well. Okay, we still have the word slope in math. But the mathematical definition is just a little different. So the slope, and we usually say the slope of a line, okay, is the ratio. And remember, a ratio is just a fraction. Ratio of the rise, okay, which is the vertical change. Remember the little triangle means change, okay? So the slope is the ratio of the rise, your vertical change, to the corresponding run, which is your horizontal change. Okay? So if we're thinking about a graph, the vertical axis is your y-axis. So when we're talking about the vertical change, we're talking about the change in y. Okay? And when we're talking about the horizontal change, we're talking about the change in x. Okay? And if you think about rising would be up and down, running would be left and right. So rising, y, vertical, running, horizontal, x. Okay, so those all of those words go together. All right, so how does this work for us? Well, let's look at the coordinate plane, and I'm just going to draw a quick sketch of a graph here, okay? And I'm going to put 2 points on this graph. Okay, I'm going to put point A and point B. Let me go ahead and draw my unit so you can see. There we go. All right, so if we want to know the slope between A and B, remember we're looking for the horizontal and the vertical changes. Okay, so the first change we want to look at is the rise or the vertical change. So what is the difference, the change between A and B vertically? Okay, well right now B is at 3. Okay, so right now B is at 3. So we want to know the difference between B and A is at 1. Okay, so the difference between them would be 2. Now looking horizontally, B is currently at 1, 2, 3, 4, 5. And we want the difference between B and A is at 1, 2, 3. So the difference between them would be 2. Okay, so remember it's a ratio, the vertical change over the horizontal change. So our ratio is 2 over 2, which is equal to 1. So our slope of that line between those 2 points A and B would be 1. All right, so just so you know, we usually use the letter M to indicate slope, the letter M. Okay, so looking again, let's look at the same problem. M, our slope, is the rise over the run. Okay, so the difference in the rise, so vertical. Okay, we started at 3 for B. Okay, on the vertical axis, we started at 3, and then A is at 1. So we want the difference between 3 and 1, so 3 minus 1. Now horizontally, B was at 5 to begin with, and A was at 3. So we want the difference between 5 and 3. Okay, so 3 minus 1 is 2. 5 minus 3 is 2. So we end up with 1 as our slope. So I just did the same problem. I just wrote out all the steps so you can see it clearly. Okay, so from somebody, after doing this over and over and over again, said, oh, well, let's make a formula so that way we can help remember how to do this. So I'm going to talk about the slope formula. The slope formula. And once you know this formula, you can calculate slopes as much as you want. So m, which stands for slope, is equal to the rise over run. Remember, rise is change in vertical, run is change in horizontal. And your rise is the difference between your y coordinates, so y2 minus y1. Your run is the difference between your x coordinates, so your x2 minus x1. So that is your slope formula. And you're like, well, wait, where are you getting y2 and y1? But if we're looking at two ordered pairs, xy, xy, well, this x and this x are not necessarily the same, so we're going to give them a subscript and say, well, this is x1 and this is x2. This is y1 and this is y2, right? Because this is point 1 and this is point 2. All right, so let's go ahead and try an example. Okay, this time I'm not even going to give us a graph. We're just going to have points. Okay, I want us to find the slope of the line passing through the points 2, -3 and 4, -1. So again, we have 2 points. We have point 1 and point 2. So we're going to go ahead and label our x's and y's. This is going to become x1, y1, and this will become x2, y2. All right, so we've got 2 points, which means we can use our slope formula, right? Our slope formula says that m is equal to our rise over our run. So our rise is the difference between our y values, and our run is the difference between our x values. So the difference in the y's is y2, which is 1, minus y1, which is -3, over x2, which is 2, minus x1, which is, oh, I'm sorry, x2 is 4, right? x2 is 4, minus x1, which is 2. So 1 minus a -3, that's really saying 1 plus 3, so that gives us 4, over 4 minus 2, which is 2, and then 4 over 2 reduces to 2. So the slope of the line passing through the points 2, -3 and 4, 1 is going to be 2. Okay? And we can verify that if we were looking at the graph. Okay, so we have the points 2, 3. So 1, 2, 1, 2, 3. So we have a point here. And then we also have a point at 4, 1. So 1, 2, 3, 4, up 1. Okay, so we have a line passing through those 2 points, right? Passing through those 2 points. All right, so we want the rise, the difference, okay, from this point to this point vertically, okay, which is 1, 2, 3, 4, okay, so that's 4. And then horizontally, what's their difference? So here's from 1, 2. So they're only a distance of 2 horizontally, okay, so you get 4 over 2, which again reduces to 2. All right. Well, now I want to talk about just general slopes, like general slopes. If you have a line and it is going upwards, this is going to be a positive slope. So your m value is going to be positive. And if you have a slope that is going downwards, like say like this, it's going downwards, so it is going to have a negative slope, which means that your m is going to be negative. Okay? Well, what about if we have a slope or a line like this? What if we have something that looks like, here's our plane, and we have this line. Okay, well, it's a horizontal line, and so horizontally, there's lots of changes, right? So remember, slope is rise over run. So the run part has a lot of changes. But the rise part has no changes, and no is associated with 0, which means that you have 0 over all those changes in your run. However, 0 divided by anything is still 0. So anytime you have a horizontal line, your slope will be 0 because there's no vertical change. There's no vertical change. All right, let's look at one more case of what your slope could be, right? We did positive, negative, we did horizontal. So now let's look at a vertical line. Okay, so we know that the vertical line does not pass the function vertical line test. So since it's failing the vertical line test, it's not a function. So if you can remember that, if it's not a function, it doesn't have a slope, right? So if you can remember that, you're good. Undefined slope, right? It's not even a function, can't even have a slope, it's undefined. Okay, if you can't remember that, think of it like this. You have a lot of vertical changes on your rise. Lots of changes going on your rise. However, you have absolutely no changes on your run. It's not changing at all on your run. So you would have a 0 for your denominator. But we can't have zeros in our denominator. It's impossible to divide by 0, giving you the answer of undefined slope. All right, that's all I have today for you. So you are going to be doing 3 problems from this section. This is 8.2. The problems start on page 242.